Welcome to Easy Higher Mathematics.
Boolean Algebra. A complemented distributive lattice is called Boolean Algebra. That is, a Boolean algebra is distributive lattice with 0 element and 1 element in which every element has a complement. Usually, it must be a lattice first. Every lattice need not be distributive, so it must be distributive lattice. Then it has 0 and 1 element. 0 is the GLB and 1 is the LUB, and every element of that set has a complement. A Boolean algebra is a non-empty set with two binary operations and OR, and is satisfied by the following conditions. So these are the separate conditions: lattice condition and distributive lattice condition, and the complementary conditions. Finally, existence of 0 and 1. So first one, that is A and A is equal to A or A is equal to A. This is idempotentilla. First one is idempotentilla. The second one is A and B is equal to B and A or B is equal to B or A. This is commutative. The third one is associative law, that is A and B and C is equal to A and B and C, as well as replace this and by or. The fourth one is absorption law, that is A and A or B is equal to A. It is here which one is repeated, that is your answer. That is here A is repeated, so A is the answer, as well as we can interchange this and or. That is called a dual. A or A and B is equal to A. Here and first, so we can interchange or by and. That is A or A and B is equal to A. Which one is repeated? That is the final answer. The fifth one is distributive law. And the sixth one is the duality of fifth one, interchanging and or. The seventh one is 0 existence of 0 and 1, as well as it is the complement of every element. The last one, there exists a corresponding element A dash, and we can get A and A dash is equal to 0 and A or A dash is equal to 1. That is the last one, A and A dash is equal to 0 and A or A dash is equal to 1. So these are the total 8 conditions to verify whether the given set is Boolean algebra or not. So let us go through some properties or some Boolean expressions and how to evaluate the Boolean expressions. To evaluate the Boolean expression, we need these 4 properties. That is, 1 and A is equal to A. Here 1 is the supermost element, 0 is the least element. So when you take the operator and, we get the smaller element only. So 1 and A is equal to A, 1 or A is equal to 1. If you take the OR operator, you can get the greatest one. So 1 and A, 1 is the supermost, so that is equal to 1. Also when you take operator with 0, 0 is the least element, so you can get the greater element A, and we can get the smaller one, that is equal to 0. So these are the 4 properties of 0 and 1. Now let us go through some expressions, how to evaluate the Boolean expression. Now let us take an example. AB plus ABC plus ABC bar plus A bar BC. Here plus refers OR and multiplication refers AND. So since the first two terms contains AB as common factor, so this can be written as AB into 1 plus C. You take the remaining as same. Now 1 plus C. 1 plus C is equal to what? A or B, that is 1 or A. Since 1 is the supermost element, for R we get the greatest element, that is equal to 1 only. So 1 plus C is equal to 1. Then remaining the same, ABC bar plus A bar BC. Again, from these two terms, once again AB as common, that is AB into 1 plus C bar plus A bar BC. Again apply the same formula, 1 plus C bar is equal to 1. This is not an ordinary multiplication, AB into 1. Its meaning is AB and 1. And 1, if you take and, we get the smallest element. So smallest element is AB only. So AB into 1, that is equal to AB plus A bar BC. Now we take B as common, that is B into A plus A bar C. But we have the formula. What is the formula? A plus A bar B is equal to A plus B. So A plus A bar C is equal to A plus C. So this is our required simplified term.